How are you doing? Oh, oops. I don't know. It's a little bit strange giving this lecture for 3 people because like we wanted to today. I wanted to talk about writing papers and giving talks, but I mean honestly, I'm almost compelled to like do an interactive little thing. But I don't know, maybe not each of you can give it a shot to give a talk. I don't know. What do you guys think? Should we just like? Why don't we? Hello. 2 more people. Okay. Now it's basically a group, 5 people. We can give the lecture for 5 people. And you say, yeah. Okay, so one thing about the, okay, let's just get started. So one thing, on next Tuesday, we're going to have these project updates, which is going to be 2 minutes per person. On the website, it says 3. It's going to be 2 minutes. I'm also going to post on Piazza again. And let me just be precise what I expect for the project. One more person. Now it's 6 people. Amazing. So what do I expect for these project updates? The point is kind of to just give a 2-minute update to your project. So answer the how my questions, which we're going to go through today again. And then I want you to present the result of the simple experiment, right? The one that we have assignment number 4 about. You present that experiment and you discuss it very briefly, and you just describe what your anticipated final experiment is going to be and what the outcome of that final experiment is going to be. And that's it. Does that make sense? Okay, good. And there's a goal here, which I encourage you to, if you want to stay in academia or not, you should take every opportunity you can get to do public speaking. I think of all the skills that I have learned in life, also Isabel, I haven't gotten back to your email yet. I'm sorry. I'm gonna. It's over this. So of all the skills that I have learned in life, I think public speaking is the most important one. It's like by far the highest impact thing. You should take any possibility you can get to publicly speak, and we're going to talk about that a little bit today. So importantly, it's basically view any of these like kind of in-class things as a low-risk platform to try out stuff for public speaking, and we're going to talk about that later. So today's lecture is going to be very light. Also, someone is going to have the PhD defense in this room afterwards, so that is an additional motivation to keep it short. So let's first do a little bit of a refresher. Geometric deep learning is what we discussed last time. That was the densest lecture of all of them, but I think it was very fun. So just as a reminder, we discussed like that convolutional neural networks have this property so-called translation equivariance or shift equivariance, and we basically formalized what that means compared to like fully connected neural networks, right, which don't have that property. And we said, oh, but there's like other kinds of transformation groups that we might want to be equivariant to, such as rotations. And we discussed that CNNs, for instance, are not by default rotation equivariant. And we looked at what that looks like, right? So if you rotate the input to your CNN and you visualize the output and you stabilize it, then you see that the output is not stable with respect to the rotations. And we also discussed that there is a way of building that. And if you did that, if you had that property, this is what it would look like. And then just as a brief refresher of how that looked like, the key idea was basically, like we first formalized the notion of equivariance. We said equivariance means that the operator of the neural network commutes with the transformation. So for instance, if we have, in this case, a rotation, then we want that if we take our image and we, for instance, do segmentation with our neural network, then and then we apply the rotation, like here, then we expect that if we take our input and we rotate the input and then we apply our neural network, it should give the same output, which in this case is not the case because this is just a normal shift equivariant neural network, and you can see that these two aren't identical, which means that this neural network is not rotation equivariant, right? Any questions so far? Okay, cool. Then we discussed a way of doing that, and I'm just going to go through that really quickly. But basically, I mean, the high-level idea was just in the same way as you get shift equivariance by shifting a filter over the image, you get rotation equivariance or equivariance to any other group. Like there's one simple way of doing it. This is the naive way. This is called group convolutions. This is not the only way of doing it. It's just the simplest way of doing it. And the way to do that is to discretize the group. For instance, if you're interested in being equivariant to rotations, you discretize the rotation group. And then you basically take your filter and you rotate it. And you basically convolve your image many times with the rotated filter, and then suddenly you have a signal which is which has x, y for shift, and then it has the axis for rotations, where every rotation is a different angle. And now you basically this is like the first layer of your neural network. This is called lifting convolution, where you take your input and you lift it into the space of the group that you're interested in. In this case, it's the rotation group. So we lifted it into the rotation, into the space of rotations. And now we discussed, so this is kind of the first layer. So the first layer is straightforward. You just take the filters that you would normally use and you rotate them. But then the question was, what do you do afterwards? So after the first layer, you still need to ignore all the math. But after the first layer, you now need to build a neural network that takes this volume as input, right? So this is the volume we generated in the first step. So this is the x-axis, this is the y-axis, this is the rotation axis. And now we need to build a filter that takes this volume as input and again is rotation equivariant. So we need a filter that again, like we need to discretize the rotation group again. So we need to like rotate the filter around. But in addition to rotating the filter around, we now have this additional property that because the filter takes this whole volume as input, so it's like x, y, and rotation, now the filter has as many channels as well. So it has one channel for each of the rotations. Now, when we rotate that filter, not only do we have to rotate it, we also have to like periodically shift this axis around. And if we do that, then we get exactly the output that we expect, which is that in this image where there's two smileys, one of them is rotated like that, and one of them is rotated like that, we will get two matches exactly when the filter has these two rotations. So just as a brief refresher. So the whole point of this is I don't know if you guys would feel after this lecture like ready to implement this. I don't know. I don't think we went quite into the enough detail for that and like to really deeply understand it. But the point is to if you just get the high-level idea from it, I think that is already valuable. And we discussed these limitations of that. That basically, this is a cool idea. It's actually a very, very important idea. It's a very practically important idea, which in vision, however, not many. There are some papers which, I wrote a paper on like doing this for robotics and stuff, but there aren't that many papers that exploit geometric deep learning in vision yet. There's many more in AI for science. Actually, I'm curious, do you deal with geometric deep learning at all in your research?
Yeah, I build equivalence with respect to Euclidean transformation.
Ah, great. So like an E3 or like E2 equivalent neural network?
Yeah.
Cool. In the Fourier neural operator or?
No.
Ah, cool. But yeah.
Dynamic model for sleep.
Cool. So you see there are, in AI for science, this is a practical thing. And do you do it with group convolutions as well, or do you do it with like another?
No.
Cool. So you do it with transformers.
Actually, you first build the invariant for energy.
Gotcha. Okay, cool. So here's another way of doing it. So like that is so there's many different ways of doing it. This is one of them. So like yeah, great. So that's the whole point. And just now note that in 3D, like right, if you look at images, like the point of this lecture is inverse graphics. In inverse graphics, you have a bunch of these transformations that act on the 3D world, and you observe images of these 3D transformations. And so it's very apparent that these equivariance properties are very important. This is something you can discover from data. Like if you do data augmentation and you can augment your group, so like you have a guarantee that you observe every possible configuration with respect to your transformation, then you're good. But you don't have that in the real world, and this remains a big problem. And this is an unsolved problem in vision. Okay, so today's lecture will actually be very. So that was just a brief recap. Today's lecture will actually be will be short, and it'll be hopefully a little bit interactive. So today I want to talk about two topics, which are how to write papers and how to give talks. And some of these slides are stolen from Bill Freeman, who wrote them, but some of you came late. Next Tuesday we're going to have the project updates, which is every project group has to present 2 minutes, just 2 minutes. On the website it's set 3. I'm going to update it 2 minutes for their project update. And what I expect, I'm going to briefly go back to the slide. What I expect is that you're going to briefly go through these high mark questions, which we're going to repeat today. And I want you to discuss the outcome of the simple experiment that you scoped out for assignment number 4. And then I want you to just scope out what your final experiment is going to look like. So what is that you're going to present in your final project report. And the reason why I think that it makes sense to give these project updates in person is because that public speaking is a very important skill, especially in science and especially if you want to stay in academia. But even if you don't want to stay in academia, if you want to do a startup, it's approximately as important. And this is a great way of, like this class is a perfect way of doing a low-risk experiment in public speaking. So we're going to go through like some things later on, like we're just going to talk about them, on like things that you should do when you do public speaking that you might not be doing. And it's really hard to change these, to learn how to do them. And this would be a great opportunity to try them out. So if you want to experiment with things that you might not otherwise experiment with in public speaking, this would be the right choice, the right time. Okay, cool. So how to write papers, how to give talks. This is also relevant to the final presentation. So some of these things might be obvious, but I think it's still worthwhile going through them, and it's still worthwhile going through them. Okay, so these slides, as I said, are from Bill Freeman. I think he must have made them 10 years ago. So I updated some of them, but they're like, actually they were in the 4:3 format. And so I copied them over to the 16:9 format. But I think they have a particular aesthetic to them, which I appreciate. Okay, so this is actually the first thing that is good talking about. I found this to be true myself. Who has seen this plot before? Okay, 2 of you. Okay, so this is a plot that Bill is very, I wouldn't say famous for, but that is very well known from Bill. This is Bill's opinion of a paper's impact on your career. So Bill is plotting the quality of a paper relative to the effect on your research career. And what he's basically saying, and it's absolutely 100% true, is that what is surprising about this plot? Some of you might expect this plot to be a linear function. It's like a linear function of like going maybe from bad, which has a negative impact on your career, to good, which has a positive impact on your career. In practice, this is skewed by several things. The first thing that it's skewed by is that no one actually reads papers. Reading papers is a lot of work, as you know. If you really want to read a paper and you want to understand the paper, it's a lot of work. So what happens is if you write a bad or an okay paper, people look at it and then they don't read it. So even if people would think it's a really bad paper, if they would spend the time of actually reading it, if you write bad and okay papers, the reality is people just won't spend any cycles on it and they won't think about it. Obviously, if you do something malicious, or like, I don't know, you do something that is fraudulent, that's a bad idea, obviously. Actually, writing bad papers in general is a bad idea, that's the point. But you would be surprised, like, basically the impact of bad papers on your career is like not that large. If you only write bad papers, that's bad. But if you have a few bad papers, nothing happens, right? Like, what is a bad paper? It's just a paper that doesn't have anything surprising, that's not interesting. Okay, the interesting thing is that the impact of okay papers is also basically nothing. What is an okay paper? Like 90% of CVPR papers are okay papers. Okay papers are papers that you read, and you read through them once, and you're like, sure. And then you're like, makes sense. You can do it. You can do that. And it worked. Great for you. You improved the number by 1%. Everyone's excited, right? Those are okay papers. And the impact of okay papers on your career, like the first okay paper is good. Like if you, for instance, apply for industry jobs, the impact of one okay paper is great. If you have 0 papers, going to 1 paper is great. If you have 5 papers and you write 1 more okay paper, the impact is 0. No one cares. It's just completely irrelevant. This is even more true as you become a faculty member. Like, for instance, for me right now, if I write okay papers, it's just completely irrelevant. It's like a waste of my time. And for you, it's actually also a waste of your time. So don't spend time working on okay stuff. Like, work on stuff that has the potential at being creative, original, and good. So, and this is now the important thing. If you only write 1 paper in your whole PhD, but that 1 paper is a paper that no one saw coming, that is going to be the thing that you need for whatever you want to do next, be it a startup or applying for faculty or whatever it is. You don't need 10 papers. You need literally one good paper. Right? So like, and this is certainly true for many professors at MIT. If you look at like what they published before they became faculty, sometimes it's like 5 papers and 1 of them was really good. And that's the thing that you give like your faculty talk, the talk that you give about your thing, that's often about basically 1 paper. Like a good faculty talk oftentimes is about 1 paper. My faculty talk was basically about, 1.5 papers. So it's like only 40 minutes. So, okay, so this is something good to keep in mind. So, okay, good. So then next, and this is related to what we just talked about, what's the image of the research community, right? So this is also important when you give talks. This is a recurring theme. Many of you, like at least me, we are very nervous about stuff. Like we're nervous about putting stuff into the world, right? Like writing papers, we're nervous that people scrutinize them and then they are critical. When you give a talk, you give the talk and you're afraid that people sit in the audience and they're like, like if I give a lecture, I'm afraid that the students sit in the lecture and they scrutinize and they are critical of what I say, right? And that's our image. Our image is like scholars are these people that have like lots of concentration. They have plenty of time in their hands. Everything you put out into the world, they are very like careful readers. But in reality, and this is why bad papers and okay papers don't have that much of an impact on your career. In reality, like the research community is like a busy market where there's like hundreds of people screaming at you and everyone wants your attention. And you don't have time. So you walk through it and you will only go and like look at the most flashy stuff, right? And the stuff that looks coolest or most intriguing or most surprising. And this is true for many things in life. So most of the time, if you do anything, no one cares. The only thing that people care about is that if something is like either catastrophically going wrong, people will care about that, or if something looks really cool. So that's why that helps, and we'll see that again with public speaking, it's the same. Okay, good. So now let's come to the technical part of writing a paper. We talked about these before, but I'm not sure if I told the story back then. So there's this notion if when you write a paper or when you scope a project, actually like whatever you do where you have to scope out anything or you write or communicate anything, there's this really useful Hallmeyer catechism. So who is this guy, Hallmeyer? This is Hallmeyer, George Hallmeyer. He was the former director of DARPA. So what's the job of DARPA? What is the job of a DARPA director? The job of a DARPA director is you get a budget. Like I know your budget is $50 billion. And then you have like these program officers, which are tasked with setting up projects, which basically each project maybe has, I don't know, $50 million in funding or $100 million in funding, like the DARPA self-driving challenge or something like that. And then they try to convince, or like, and then basically universities and other things apply for that funding, right? And these program managers would approach George and pitch projects to him. They would be like, hey, I want $100 million funding for the DARPA self-driving autonomous navigation challenge, right? And then George had to decide whether to say yes or no. So George very directly had an incentive to do a good job at figuring out if projects were worth funding or not. And so George developed this like very simple framework. So like he asked everyone when they would pitch projects to him to answer these questions. Like he basically said, like, look, like these are the questions you have to hit. Every time you pitch me anything or every time you communicate anything to me, just make sure you're hitting these points. So first one is the problem definition. What are you trying to do? One thing I left out there, he always says without any jargon. Like if I don't know any of the words in your problem definition, bad news. You're probably not getting any funding, right? You have to, like, if you pitch the problem to people, the problem definition has to be easily understandable. And this is the point where it comes in to know your audience, right? Like, who are you talking to? Like most of the time, when you give a faculty talk, for instance, this is very important. Who is the audience? The audience might be people that, for instance, for a faculty talk, they might be people that are very smart and they are academics, so they have like very good fundamental knowledge, but they might not know about your research area in particular. So if you start throwing words at them from your research direction that they don't know, then everyone's going to switch off. It's going to be bad. Same for papers. If you write the paper intro and the paper intro is full of jargon that like only people understand that have already read all your other papers or that are very familiar with that line of research, bad news. So problem definition, what are you trying to do? No jargon. How is it done today? And what are the limits of current practice? So the problem that you defined, probably people have attempted it. If people haven't attempted it, it's probably not a very important problem. So probably people have attempted it. The people that have attempted it, how did they do it? Again, very high level, right? And why did it not, like what are the limits? Like that doesn't mean why did it not work, it just means what parts of the problem are unsolved. So what are you unhappy with? So if you're pitching your project update, or when you're writing your project report, or when you're writing a paper, in your introduction, oftentimes you can go through the introduction of any given paper and you can identify the paragraphs. Oftentimes the first paragraph of any paper is the problem definition. Like this is an important problem. The second paragraph is, you know, I don't know, lots of people have tried to solve this problem. And like it looks really good, here's a bunch of papers, but this is how they fall short. And then the third paragraph is, what is your approach and why is it better? So you usually, that's when you introduce, that's the context that you need to establish what are you doing, right? So what is your approach and why is it better? I mean, that should be self-explanatory. And then these are a little bit specific. These are not as important for writing papers. These are more important when you pitch a startup or when you apply for funding or when you write a grant. But even in a paper, sometimes they are important. So who cares? If you are successful, what difference will it make? So if you do the things that you set out to do, what will the actual impact be on the world? Like, will people actually care? Will it like, what is the real world problem that you will actually have solved? How will the life of people change if you do this, right? So clearly for a startup, for instance, if you go to a VC and you want money for a product, that's really important. For papers, usually it's a little bit more clear. Okay, and then final, this is actually really important. What are the midterm and final exams to check for success? So when you scope out a problem, this is a mistake that I make and that many people make very often, is that you don't define what success looks like. So maybe you set out on your research project, and many students, when they're junior, or many academics like me that make mistakes in their project scoping, they scope out their problem wrong in the sense that they don't define what success looks like when they start out with the project. They basically don't. What that specifically means is you identify what is going to be the final experiment and the outcome of that experiment that will convince you that it's working, and that will convince everyone else that this is important. Like what is literally going to be the video that you show to people? Like the video that you put in front of everyone and you like, look at this. Envision, it's usually video, right? Could be something else. Envision, what is the result that you put in front of everyone? You're like, look at this. This is clearly working. And everyone will be convinced. So it is helpful for like conjuring up that image in your audience's head. Like, right? Like, I'm going to build this method. This method is going to do photorealistic 3D reconstruction from a single image. Success will be, I take a picture of this room with all of you in it, I snap my fingers, and afterwards I can show you a video of like the camera flying through this room. That would be a great way of scoping success. Okay, so that's the Heimer Catechism. So Ted Adelson, who's a professor here at MIT, basically has his own version of that. Ted Adelson was the advisor of both Bill Freeman and of Philip Isola. So like actually both of his students ended up at MIT as MIT professors. You can go through this on your own time, but basically he's saying what I thought was really cute is Ted told Bill, since I developed this formula, it seems that all the papers I've written have been accepted, which I think is pretty funny. But he basically says the same thing, right? Okay, so start by stating which problem you're addressing, keep the audience in mind. They must care about it. Sometimes you have to tell them why they should care about the problem. This is the part about, you know, like, who cares? State briefly what the solutions are to the problem, why they fall short. Explain your own solution compared with other solutions, say it's why it's better. At the end, talk about related work where similar techniques have been used but applied. So I think this doesn't apply as much anymore because the paper format has shifted. Now usually you discuss the related work at the beginning of your paper. But the reason why so this is my own slide. This is the slide from Bill. But like, I don't know if Ted was aware of the Heimer Catechism, but you can see this is a very general framework. Okay, this we're going to skip. The only thing I think that is worthwhile, that I think is something that is worthwhile many people, when they write their paper, so this is the structure of a general paper: introduction, related work, image model, algorithm, experiments. This is just a vision paper. But then at the end, you have this future work section. And Bill and Ted actually thought that the future work section was a waste of space, which I think is at least an interesting thought. So Bill says, I can stand future work sections. It's hard to think for a weaker way to end the paper. Here's all the ideas that we wanted to do but couldn't get to work in time. And it is also true you don't really get any brownie points for it, right? It's not like someone will read through your future work section and then they'll be like, wow, these ideas are so great, I better accept this paper because these are all the things you didn't show in your paper. And why would you give all the best ideas away for the reader of your paper? So I think there is some truth to this. Usually, like discussing future work in detail is probably a waste of time. There's not really any point to it. Yes.
Well, I think for many papers there is like a lot of them are like presenting a method that it will enable something in the future, right?
Mm-hmm.
So, for example, when you shared like how to make camera poses more accurate.
Yeah.
That is like enabling a better reconstruction after all, right?
Yeah.
So if you write a really hardcore method on like improving camera position, reconstructing camera positions, then isn't it?
Great point. If the moment where your reader understands that your algorithm will enable these future applications is the future work section, then you wrote your paper wrong. But this is but this is actually really important, right? Like this is exactly true. What you said is exactly true. It's really important that like you conjure up the image at the start of your paper, not at the end. At the start of your paper. Otherwise, what happens, right, is the reviewer or the person who reads your paper, they will read your paper and they will be puzzled all the time. Like, why are they solving the problem of camera pose estimation? Why would I care about that? Ideally, in the introduction, you tell them, you know, this is such an important problem. If we not nail this, then these are all of the cool things we will be able to do with it. And then the future work section is kind of superfluous. But I do agree. This is like I do agree that there might be things you might want to discuss. But I think it's at least good to think about this, like because really you should be the reader of your paper should already know about this at that point. But yeah, good point. So, other points, questions, concerns? Yes?
I guess this makes sense for like writing a paper, like not wanting to really give ideas and stuff, but as like a student looking for projects, I think I enjoy future work sections. It's like a nice way to kind of inspire directions that like I guess we'll figure out and like I might have to do something.
No, and I think it's a good analysis. There are some academics which are better people than I am that spend the extra time of like having a list of problems that they don't have the time to work on, but that I forgot, I think there's one guy on Twitter who does this. And I actually think that's really cool. So it's like they have this running list of projects where they say, if you want to work with me, here's a list of projects that I have scoped out to different levels, to different degrees. And if you pick any of these projects and then they have like, maybe they define the first experiment. They say like, look, this is the first experiment that I would run. If you write me an email and you send me evidence that you ran the first experiment and you show me the outcome, then I'm going to work with you. And actually, I think that's really cool, right? And in a way, this is actually a good way to approach project management in general, or like if you work with undergraduates or if you supervise anyone. This is, in research, actually a fair way of approaching it, right? You're saying like, look, here's, you can do whatever you want. Here's a few things that I think are exciting. If you nail this first experiment, then it's evidence that we should go further in this direction. But yeah, I agree that this is kind of a bug of academia to a degree. Cool. Other questions? Great. General writing tips. I mean, these are, again, some of these are obvious, but I think it's good to discuss them and to recall them every time you write a paper, because otherwise it's easy to ignore them. So Donald Knuth, who some of you know, he's the inventor of LaTeX and the writer of the book that maybe some of you had to work through when they learned C++ programming. What is it called again? The Art of Programming. Said, perhaps the most important principle of good writing is to keep the reader uppermost in mind. What does the reader know so far? What does the reader expect next, and why? So another way of putting this is your paper, writing good papers is like writing a good story, right? It's like, and Bill extended this by the following idea. Treat the reader as you would a guest in your house. So like, as you go through your own paper, really try to make sure that you have a model of the reader's state in mind when you go through the paper. Like, what do they, like when you read through the paper, what do they know? What do they not know yet, right? And then you should anticipate what is the question that they're going to ask. And when we give talks, this is going to come up again later. This is my favorite, like, there's many things about giving talks that you might have heard about before, but there's one thing that maybe you haven't heard about before. But this will come up again. So basically anticipate people's questions. This is really important, both in writing papers and writing talks. Like when you read through your own paper, assume that you are like someone who has no idea or like someone who has a medium level of idea, and you go through the paper and you basically mentally keep note of what questions might arise and what questions you have answered yet. And like that will be good. Okay, like keep it concise. I mean, this is, I mean, just to point this out, right? Like if you write a paper and just really get rid of all the slack, like literally anytime you write, also when you write project report, like for the project report that you're going to write for this class, you don't have to try to stretch it out to 2 pages. You're not going to get brownie points for that. Like if it's only half a page, I'm happy as long as content is there, right? But like just definitely cut down any superfluous words in your text. Anything that doesn't serve a purpose, everything flies out. When we write papers in my group, we literally go through every sentence. We kick everything out that doesn't serve a point. There's no point. It's just like taking up mental space in your reader's head. So just keep it short, right? So I don't know, you can go through this, but like if you look at the first 2 sentences, the underlying assumption of this work is that the estimate of a given node will only depend on nodes within a patch. This is a locality assumption imposed at the patch level. This is not a bad sentence. It's also not wrong or anything, but it is the sign of like someone has not spent the time at making this concise. If you make it concise, we assume local influence that nodes only depend on other nodes within a patch. That's a concise sentence. So like the more time you spend on a text, the shorter it should get. And you can literally see it in your own writing. If you write a paper and then you spend like half an hour or 1 hour of like just taking the text that you've written and you just shorten it down, the text will actually get like, can shrink by 20%. It'll get strictly better, I promise you. Paul Graham, which some of you might know, he's like an investor. He's one of the founders of Y Combinator. Paul Graham always points this out that like, he writes lots of essays he publishes on his blog, and he always says like the first draft of his essay is like 30% longer than the final version of his essay because he just cuts it down. And this is like a really important part of writing. Okay. I mean, this is basically, there's different kinds of readers for your papers. There are some that read only the title. That's most of them. Some only look over the figures. Some only read the abstract. And very, 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 very few of them read every word. And unfortunately, it used to be that the reviewer reads every word, at least the reviewer. Nowadays at CVPR, I'm pretty sure that the reviewers have shifted left on this plot. So like basically, because there's 16, at CVPR this year, there's 17,000 submissions. This year CVPR has a record number of submissions. And like, I mean, every student in my group is now a reviewer for CVPR because we've signed up everyone. Because otherwise, there's no way you can review that many papers for everyone. It's crazy. But yeah, so it used to be that reviewers read, like, at least the reviewer reads every word, but in practice, many people don't. And you have to make sure that there's this idea, right? There's this heuristic that if someone only looks at the figures of your paper and the captions, then they should understand what your paper is about. And again, you can think about this as a way of like answering these Hamai questions, right? When you write your paper, one thing that sometimes makes sense is having like a teaser figure or a little tiny overview figure. In many CVPR papers these days, you can see this. There's like the two-page layout, the two-column layout. In the top right of the first page, there's going to be a tiny figure that is the input-output behavior of your model. And so then that's basically answering the first question. What is the problem that you're solving? Well, here's the input-output behavior. That's the easiest way of discussing the input-output of what problem you're solving. Is the input-output behavior of the model. Then maybe the next figure is oftentimes the related work. Sometimes people make a figure for the related work or a table for the related work, where they basically have this like, they have like different different dimensions of like what the model does. So maybe, I don't know, in computer vision, it might be we discussed light field transformers and like radiance fields, for instance. So maybe one dimension would be 3D structure. Like, is it actually a 3D representation or is it a geometric model or not? Another one might be like, you know, I don't know, ray marching for rendering or something like that. And then they have these rows of the table. Each row is one related work, is one piece of related work. And then they have a check mark or a cross. Should have put that on my table. But I'm sure you've seen this before. So that's basically answering the second question. What have people done before, and how does it fall short? And actually, these related work figures are really useful, especially in computer science. Like making these tiny tables, they use very little space, but no one wants to read related work sections. So actually, I really like little figures or little tables for related work sections. It's usually at least a good exercise for yourself before you start a project, making that table yourself and clarifying for yourself what are actually the axes along which I want to innovate and the axes at which I expect to be better than related work. Any questions so far? Great. Paper titles, I also find this very amusing. So Bill, of course, is a much more experienced academic than I am. So here's paper titles. This is from 1990. This is the year in which I was born. So here's paper titles. Theory and implementation of wavelet and multidimensional transforms. Non-separable multidimensional perfect reconstruction banks and wavelets for Rn. Multi-resolution analysis, Haar bases, and self-similar tilings of Rn. I have no idea what any of these papers do. Bill identified a mistake he had made earlier in his career. His paper title was Shiftable Multiscale Transforms. And looking back, he says his paper title should have been What's Wrong with Wavelets? I don't know if you guys have written papers like that, or I always have a hard time coming up with snappy titles. I will say that the most popular paper that I wrote had a really snappy title. So I do think there's like some truth to this. I haven't gotten into this habit myself. Have you guys written papers with like funny or snappy titles? Clickbait. I don't know what's wrong with wavelets. I wouldn't call it clickbait. I mean, but fair. I think this is good. So these are we actually discussed. Yeah, go ahead.
I just want to say, in our group we often use like little like names or acronyms for papers.
Yeah.
Especially we often develop like tools. And sometimes there's just too many.
No, but I think it's a great point, right? Like in this class, we've discussed a few papers, right? That refers to some of them. NERF, neural radiance fields, right? We discussed Siren, sinusoidal representation networks. We discussed PixoNerf, it's a really snappy title. SRT, like scene representation transformer. Scene representation transformer is not a snappy title. SRT is fine. A recent good one is, well, BARF. I don't know how I feel about that one. But then there's, for instance, Dynabar. Like there's like lots of snappy titles, and I do think it does help. So here's a few that Bill thought were memorable. What makes Paris look like Paris? What's the frog's eye? What the frog's eye tells the frog's brain, and unbiased look at dataset bias. Another good paper title was Building Rome in a Day. That was a structure for motion paper we discussed. Right, that's a great title. Building Rome in a Day. It's like that's a genius title. Noah always comes up with good ones. If you want to see lots of good paper titles, look at Noah Snavely on Google Scholar. Noah is like every paper title is a banger. Okay, I mean, figures and captions, right? Like, I mean, you don't actually have to look at anything in this paper. If you only just look at this figure, you know, I don't know what this paper is about, but there's no question about what the method does. Like, method makes artifacts go away. I don't know what the method is, but this appears to be the key point of the method. Now we can read the caption, and I'm sure the caption explains how it makes it go away, but I don't think you need to actually even need the caption. And this is something that is obvious. Again, this is an obvious thing that your advisor probably tells you, but like, again, remind yourself every time you make a figure. You shouldn't need a caption to figure out what's going on in the figure. If you make a comparison figure and you look at the comparison figure and it's not immediately obvious what the differences are between the baseline and your thing, you're doing it wrong. Like, it has to be obvious. If it's not obvious, you failed. If it's not obvious, make it obvious. Make an inset or highlight or like an arrow, anything that, like, you know, the viewer will look at this figure exactly once, and if they're confused about what's happening, it's over. They're gonna be like, okay, this is garbage. Like, what? You have one shot. This is also good. Donald Knuth on equations. Many readers will skim over formulas on their first reading of your exposition. Therefore, your sentence should flow smoothly when all but the simplest formulas are replaced by blah or some other grunting noise. I think this is good because, like, it relates to the second thing, which is the Good Samaritan rules. When referring to an equation, identify it by a phrase as well as a number. So all of your equations should be numbered. When you introduce an equation for the first time, it's oftentimes, if you want to ever refer to it again, you should refer to the equation, you should give a name to the equation. So for instance, if it's the volume rendering integral, you shouldn't just be like, you should call it the volume rendering integral, colon, equation, number. And then if you want to refer back to it later again, you shouldn't cite it with equation 6. You should say the volume rendering integral, equation 6. Because otherwise, right, like, no one actually goes back and looks at equation 6 again. I mean, I do that, but like, it's annoying, right? Like, if you just give it a name and you refer back to the name, then people might remember what, like, no one will remember what equation 6 was, but everyone will remember what the volume rendering integral was, right? Okay, this is also important. When you cite papers, be nice. Don't like put down other people's work. Imagine this. So ec7f7a8b is a very famous computer vision researcher. Bill was so proud when ec7f7a8b referred to his paper like this. So this is a paper from ec7f7a8b, and he cites Bill's paper like this. A number of papers to be published this year, all developed independently, are closely related to our work. The idea of texture transfer, la-di-da. In particular, see the elegant paper by Hertzman et al. In these proceedings. Right? So like, ec7f7a8b went the extra mile and was like, oh, you know, this is related work, but I'm not going to put it down. I'm going to say, like, look at this super cool paper. And I promise you, when Hertzman, who's now the chief scientist for Adobe Research, when Aaron read that, he was probably very happy about, like, how his work was cited, right? So that's great. Like, he's not going to be upset about how you cite him. So, and also, it's kind of like putting people down in your citations is like is kind of, you're giving away that you're kind of insecure. Yeah.
Like, that also serves the purpose that probably the people that you cite in your related work might read your papers.
Also true.
Then you kind of like flatter them.
Yeah. Yes. No. Totally. Like, yeah. I mean, that's maybe a more cynical interpretation, but I don't disagree. And if you're nice about people, then, you know, well, this is kind of obvious, but, you know, develop a reputation for being clear and reliable, and also develop a reputation for being nice. Like, no, like, one thing I can tell you from personal experience, if you mistreat people, or if you're like not nice to people, like, people will remember that, and it does get around. Like, people will know. If you're kind of bad, if you like write people annoying emails about, like, or you're being not nice to people. So, like, just be nice to people. Like, yeah, so, like, don't oversell your stuff. And, you know, this is a quote from, I actually don't know who this was. I think this was something that Bill overheard at like at a conference chair discussing some of the reasons behind the best paper prize selection. Because the author was I knew I could trust the results. The author was, I think, David Fleet, who is a faculty at the University of Toronto now. So, you know, like if you develop a reputation for doing reliable stuff, that's good. Okay, skip that. Yeah, this is actually also really important to realize, and it's also kind of funny. So there's two kinds, from an area chair's perspective, so area chairs are the people who like assign reviewers and make the final decision on paper acceptance, right? So from an area chair's point of view, there's two types of borderline papers. There's the cockroach. The cockroach is a paper, you know, you read the paper and the paper is crafted well. This is what I would describe as bad or okay papers. These are papers, you read them, and I don't know, they like improve the state of the art by 1.5%, and they're like entirely uninspiring, but they're novel by definition of like doing something that other people haven't done before exactly like that, but like whatever. So this is like the cockroach. So as an area chair, these papers get like borderline review scores. They get like, you know, borderline accept, borderline reject, accept. Like that's the review score for these papers. And you know, you try, but you can't find a way to kill it. You can, as an area chair, you can't be like, okay, this, you know, you shouldn't go against the reviewers' recommendations. All the reviewers are like, meh, I don't know what to do with this, like borderline accept, whatever. So the bad thing is that most of these papers actually get accepted as posters because there's no obvious way to kill them. So it's fine. If you have to write if you have a bunch of results and you need to wrap them up, you're going to write a paper like that if it's not a good paper. Okay, but then there's a better one, which is the puppy with 6 toes. This is a delightful paper, so it's like surprising, it's cute, but it oftentimes has an easy to point out flaw, and this flaw may not be important, like 6 toes and puppy, but it makes it very easy for someone to reject the paper. And the sad thing is that most papers of these do end up getting rejected, because it's obvious, like there's an obvious flaw in the paper that is easy to point out, and then reviewers latch onto it, and then they reject it. But a bunch of them get in as posters, and the truth is, if your paper falls into that category, so it like does something that's actually new, but some reviewers don't like it. Like oftentimes these papers have scores like this. It's like maybe like accept, strong reject, like because like one of the reviewers don't get it, or they really don't like it, or like I don't know, they have some problem with it. Or maybe it's like, or people don't get it, and then it's like borderlines and a reject. Then it gets reject. But if you resubmit these papers and you fix the obvious flaw, then they would get really good. And I guess this is more of a note on like don't get discouraged when your paper gets rejected. If you think it's a good paper and you think there's something actually new in it and your paper gets rejected, story of life. But like if you just try to do, like when you start a project, just try to go for papers like this. When you start out with scoping out the project, just make sure that if you answer these Heimbach questions right and you like everything works out the way it should work out, there is something that is actually surprising in your paper. Rather than like aiming for an okay paper you can publish many papers in that way, but then none of them are going to be very good. Okay. I mean, there's easy ways of rejecting a paper. You know, this is a classic one. You oversell. So like, my old advisor Gordon had another funny plot. I should steal that one. So like I should call this Gordon's plot. Gordon's plot looked like this. Like there's like the reviewer's attention span. And then there's like or like happiness, sorry. It's reviewer happiness. Happiness, and then it's like progress through paper in percent maybe. Progress through paper. Okay, and then there's like an acceptance threshold. So if the reviewer ends up at the end of it, and your paper is above the acceptance threshold, they're gonna accept it. So, and then you can go through different kind of excitement like plots. So one excitement plot is like if it's a cockroach paper, like the cockroach paper might look like this. It's kind of just like, actually, yeah, it's kind of like this. That's a cockroach. So like, you know, like no one is particularly excited about it from the get-go. They look at the introduction and they're like, oh no. It's one of those papers. I don't want to review this. I don't even want to read it, but I have to because I have to review it. So I'm not excited about it. But then you didn't violate them in any way. There's like nothing fundamentally wrong with it. You didn't like promise something that you don't deliver. Everything is kind of by the book, and then it ends up being like, okay, whatever. Okay. And then there's like the really good papers. Like there's always excitement always goes down because people get tired, right? So like, but what you want is when you write a really good introduction, and it's actually a surprising thing. You basically get to choose like the topic and the scope of the project determines determines where you start. If the project is like really surprising and the idea is really novel, then you start up really high here. The only way to, and then if you do everything right, the plot will look like that. So like the excitement will go down whatever you do. But you can think about events that will screw this up with. So like one thing that screws this is if you start high, but then you fail to explain something in the introduction. That is a key limitation, for instance. It's not even because you're trying to be dishonest. It's just because the way you wrote the introduction, you didn't do a good job reading the introduction and realizing what is the image that you're conjuring up in the mind of the reviewer. And then as they are going through your paper, they realize by themselves that you're doing something slightly different. And then they're disappointed because the method doesn't address one of the problems that they thought about when they read your introduction. These kinds of failing to deliver on the thing that you're conjuring up in the mind of the reviewer is like one of the reasons why this goes like that. Actually, that's that. Okay, references missing. This is exactly this thing. If you don't cite your reviewer, it's bad news. Are the results too incremental? Okay, that basically picks the y-axis, right? Are the results believable? This is another one, right? Like if the results are like not, like they arrive at the results section and then the results look really good, right? That's probably good. You might get a bump. But if the results are kind of like too good or they're not believable or they're like really weird, then like that also shoots you. Sure, poorly. Yeah, poorly written, right? If the paper is poorly written, how does this look? It looks like this. Right? If the paper is poorly written and it's a struggle to get through the paper, then they have to spend so much attention span to like just get through the paper that they'll be halfway through and they're going to hate it. They're going to be like, this is a waste of, this is terrible. So yeah, and this plot is useful. Cool. Bill has a bunch of more sources on writing technical papers. I'll upload these slides and you can check them out. Now we're going to go to giving talks, and it's going to be short, and then we're going to be done for today. So the reason why I want to talk about this is because you are giving talks, and as I mentioned, I want you to experiment a little bit. So giving good talks is important for a researcher. I can promise you that it's actually important for everyone who has any kind of footprint where you have to present stuff to people. Obviously, giving good talks is important. Duh. This is important. In science, there's many people who think the work is itself what really counts. And that is true to some degree. Like there's some work that is so unquestionably brilliant that like you can talk about it which any way you want and people will be impressed by it. But I don't know. I don't think I've written papers like that before. Maybe someday you get lucky, but usually I think most of us aren't in that bucket. Giving good talks is like really the thing that starts you out on a good foot with many people. So if people might have not read your papers yet, or they might not know you as a researcher, but if they go to a talk of you and you give a good talk, it has a huge impact on how they will perceive you and your work going forward. So now, what is a good talk? Let me talk about that. Actually, we get to that later. So, high order bit prepare. One thing that I do, actually I would be curious about your tricks if you have found anything that works particularly well for you. What I usually do when I give a talk that is actually important, I literally write out the whole talk, word by word, like verbatim. Like I write out the whole talk verbatim, and then you don't actually have to learn it by heart. That doesn't matter. The important part is that you write it out verbatim for you to prepare. It basically takes away a lot of the uncertainty of like being able to look at it and go through it, and then maybe being able to iterate on it and like iterate on the story as you write it out. So I can highly recommend it. So like really spell out the talk verbatim. Another thing is like training the talk, obviously. Like the most important thing that determines how good you are at giving talks is how many talks you've given. It's entirely a learned skill. So you have to just give lots of talks. Every opportunity you can. Lab meetings, courses, you should always sign up for giving the talk. It's the only way of getting good at it. I know, so the nervousness never goes away, but here's the thing. Let's ignore this. Nervousness is something that you just have to get over. It goes back to this busy market thing, like just this in the same way that writing papers, most people don't read your paper, most people don't listen to your talk. If you are in front of an audience, like 90% of the people are switched off. They just don't care. You could tell them whatever you wanted, they wouldn't notice. It's just because people don't have, like the default state is people don't scrutinize the stuff that you talk about because they don't have mental cycles for it. So that is maybe one thing that might help you get over nervousness. The only other thing is doing it many times. So the thing that has helped me most getting over nervousness is just giving hundreds of talks. So at this point, maybe I've given like 1,000 talks. At some point, you'll get over it. You never get quite over it, but like so just do it many times. Okay, so different types of talks. There's 2 to 5 minutes talks, and there's longer talks. And there is actually, there's obviously differences between the two. Let's talk about the 2 to 5 minute talks. This is again, so this is Bill's slide, but you might again notice the same pattern. If you give a 2-minute talk, what questions do you answer? You answer the how might questions. Always the same thing. You always have to answer the same questions. If you give a 2-minute talk, you better hit all of these, and that's the complete pitch. People don't need to know anything about anything else. Just if you give a 2-minute talk, make sure you're answering all these questions. Okay. Longer talks, actually, I'm going to skip this stuff because I have my own version of this. So ways to engage the audience. There's like, you can do demos. Maybe, I don't claim that I'm the best presenter on the planet, but I think when I watch other people's talks, I can tell when they're doing things wrong. So one thing that people are doing wrong, I think that applies to both giving lectures and giving talks, is they give lectures like this, or they give talks like this, because it is like lame. It's very lame. When you give a talk, and this is something that I would encourage you to try out on the project updates next Tuesday. And when I say try it out, I literally mean this is a zero-risk environment. Like, no one cares if you mess this presentation up. There's zero negative impact on your real life, right? Like, none. So, ideally, you use this talk as an opportunity to experiment a little bit. So here's a few things I encourage you to experiment with. First thing I encourage you to experiment with is walking through your audience and making eye contact with your audience and talking to members of your audience. Because this is a huge difference. You have no idea how big of a difference this is. Even if you have a huge crowd, if you just talk to people instead of talking at the general crowd of people, makes a drastic difference. So I really can't encourage you enough. Like, if you have the opportunity, get a mic that you can, even if you have a handheld mic, it is such an important thing. For many reasons. One is people feel much more engaged because I'm talking to you right now. So even though you might want to pay some attention to your laptop, you can't because I'm talking to you. So it's like, right? So you can capture people's attention so easily, and you can really drive a point home. I can talk to you in particular, and you cannot escape. It's like, you're sitting right there. You have so much power as the presenter, right? Like, I mean, he's smart because he's sitting in the back row. I've never gotten to the back row, but I could absolutely go up to the back row. And, I'm giving a lecture right now, so maybe no one ever does this. But I promise you, it's like, it seems so weird, but actually it's like not that weird at all. I could totally give a lecture, and I could totally do it. And I promise you, like, just the way you all find this amusing, when you give a faculty talk, you could literally do the same thing. And like, what would happen is people would find it amusing, and people would find it engaging, and it would be totally fine. It's in many ways a way of showing confidence, right? It's like, if you're like hiding behind the stick, like, I don't ask any questions, please. Like, if you're, another thing, if people ask questions, same thing. Like, I was recently giving a talk at Princeton, and someone asked a question. So when someone asks you a question, what you shouldn't do is you shouldn't stand back there and answer a question. Ideally, you walk up to them, and then you answer the question to their face. And why is it important? It's also important because it's kind of like a display of confidence, right? You're asking me a question. I'm going up to you, and like, I'm making sure I'm understanding the question. I'm making sure, maybe I repeat the question back at you. I have eye contact. I'm dealing with you as a human and not with a question as a general concept, right? So eye contact and like walking around is actually super important. It's like one of the biggest power moves there is. So definitely try it out. So please try it out in the next Tuesday. I encourage you to try it out. Just when you give the talk, there's nothing that can go wrong other than you feel awkward, but that's the way of life, right? Another thing is like taking breaks. I'm particularly bad at this, but like taking breaks is actually a similar thing. So when you're giving your talk, people say, oh, you have to take breaks. So I encourage, this is totally true. You should take many breaks, pauses. When you take a pause, it's actually a good idea to just really, like, maybe you ask a question, and then you just look at people, and then you take a sip of water. Any questions? Right? It's just like, just take your time. There's no rush. Like, you know, people can think about it, and like it's like it helps you getting comfortable in the situation of like people looking at you, right? Like people are looking at you. You're like, oh, I don't want to drink. I don't know. I don't want to drink, or like, you know, but like it's treated as a conversation. If someone was talking to you, you would also take a sip of water. So like just treat it as a conversation. I'm talking to you. I'm not. That maybe helps you with the nervousness as well. I'm talking to you. I'm not giving a presentation to you. I'm just talking to you. And when you're this point actually, let me double down on that. This idea of reframing presentations as talking to people. If you explain something to someone, I promise you, most of you are excited about your research. Otherwise, you probably wouldn't do it. If you're excited about your work and you get the opportunity to explain it to someone, what is the frame of mind in which you present the research to someone, right? You would probably sit in their office, or they would sit in your office, and you would talk to them, and you would probably be excited. You like, maybe you have a whiteboard, and you sketch something out, and you like tell them why it's exciting, and you have this light in your eyes. And then many people have that when they talk one-on-one, but then the moment they give a presentation, they do this thing where they go into this different mode, because that's their presentation mode. And their presentation mode mentally for them is different than their explaining stuff to people mode. But that's the best way of giving bad presentations. Like, basically, in my mind, giving a presentation is as if you're explaining something to someone one-on-one, with the difference that you're preparing your arguments with a extreme level of detail, and you have much more time crafting the story that you want to take people along. But by the way, if you want to learn how to persuade people, it's kind of the same thing. You would just craft your arguments, right? Even in one-on-one conversations. That's how you make coherent arguments, right? You like prepare them. So the right way of giving a talk when you explain something is to explain it to people as if you were explaining it to them in person. And you can facilitate that by making eye contact with people and talking to people instead of talking at the crowd. But really, don't get into this mindset of my presentation is a different thing than talking to you. It's the same thing. Yeah, one more thing is like body language, right? Like when you, it helps like making, like one thing then when you start your talk, one thing that's good if you're nervous especially, one way to start your talk and to like mentally get into the mindset of like, oh, I'm going to give a good talk, is like just, you know, resist the urge of like staying where you are and just, again, like take a step towards people and like mentally be like, okay, I'm going to engage with my audience, I'm going to actually talk with people. Okay, so here's my favorite thing. 2 ways to present a solution to a problem. I don't know, maybe I've talked about this before, but this is for the long form of talks that you have. So unfortunately, this probably doesn't apply to your 2-minute talk that you're about to give next Tuesday. But if you have time to take people on a journey and you want to stay, you want people to stay engaged, this is the magic trick. So if you're presenting a method, like a paper, then usually at a conference, the way you present it is you have 2 minutes or 5 minutes, and what you're going to do is you're going to answer the hand-eye questions, right? You're just going to go through this list. You're going to be like, this is the problem. This is why other methods suck. This is why my method is better. See you later. That's it, right? So if you have a long-form talk, like you give a talk in a seminar, or you give a talk in a group meeting, or you give a talk, your faculty job talk, or you give a talk at a job or something like that, right? What you get is you get a 45, 50-minute time slot to entertain people. The thing that people will remember is if they were entertained by your talk. That's the high order bit, unfortunately. So like the thing that people keep most in mind is how did you make them feel when they were sitting in your lecture / your. So if you laugh during this lecture, then you will probably remember that much more than if I do a good job deriving some equation, right? No one cares. So if you have this time to prepare your arguments and to prepare your story, then you should take the time to prepare the story. And here's one way of like storytelling that I really like. When you're presenting a method and you are not at a crunch for time, I call this method the you got to trick your audience way. So basically, there's 2 ways to present a solution. A direct way, so here's the problem, this is the conference way, and then there's the indirect way. Basically, you want to manipulate your audience into thinking you're an idiot. And then you surprise them with counterfactual. So basically, the way it works is you first, the direct way of presenting a method, we just discussed this is straightforward. You basically present the problem, and then you tell them what the way that you solve the problem is. The problem with this is that people will not appreciate the complexity that it took you to come up with the solution to the problem. Because you present them the problem, and then you present them the solution, and you haven't, like, people don't think on their own when they listen to your talk. you have to make them think. So if you want them to think about something, you have to make them think about the thing. So if you want them to think about how hard it was for you to come up with the problem, you have to find some trick that will make them think about it and appreciate how hard it was. Okay? And this is the trick that I found. The key idea is that you basically make them think you're an idiot, and then you convince them of the opposite. So you first introduce the problem, and you introduce the problem in great detail. Like you really, really do a good job at discussing the problem. What happens in the mind of your audience is that they will start thinking about how they would solve the problem. So step one, you propose the problem, you discuss the problem, you make sure that it's really clear what the problem is. Step two, now usually you would go to present the solution that you found, but this would be a mistake, because then they will never appreciate how hard it was to come up with a solution. Instead, what you're going to do is you're going to tell them the wrong solution to the problem, namely the obvious solution to the problem. In other words, the solution that they came up while you were presenting the solution to the problem. So that is really good. So you basically start talking, you're literally presenting, you're not telling them that you're presenting them the wrong solution to the problem either. You're going to start presenting the solution to the problem that is basically a baseline to your method. So basically you're going to pitch them the baseline as if it was the real method, okay? And you're going to do a good job at it. You're going to really explain it, you're going to actually do a good job at it. And that's the path where they think you're an idiot, because they're going to be like, oh, I came up with this. This was obvious. Like, this guy's an idiot. He's talking to us for this 40-minute time slot, and he's just telling us something we already knew. This guy's an idiot. Great. Okay, and now you pull the rug under them, because now you tell them that this solution is dumb, because here's the obvious flaw that all of them forgot. And that is how you make them appreciate that the problem was hard, because they will have spent some time thinking about the problem. For some time, they were convinced that they had the correct solution, even if they didn't come up with it themselves. Like, you took them by the hand and you showed them the solution to the problem, and they were convinced that was the right way of doing it, because you pitched it to them as if it was the right way of doing it. But it wasn't. And then you tell them, this is what happens. Like, here's the output result that convinces you that this obvious way actually doesn't solve the problem. And then you tell them the actual solution to the problem. And that is how you basically force your audience to think about, engage with the problem without just actually telling them the solution to the problem. More insights from Ted Adelson. People like to see a good fight. This is actually kind of related, which is why I juxtaposed it. So people like to see a good fight. The flat Earth theory predicts that ships will appear on the horizon as small versions of the complete ship. Think about it for a moment. You could literally apply the same thing, right? If you had a child and you wanted them to appreciate the scientific process of coming up with a solution to whether the Earth was flat or round, the easy way to do it is you could go to the child and be like, the Earth is round. Great. That would be bad, because the child will never have to go through this mental process of thinking about the solution themselves. Instead, what you would probably do is you would be like, okay, so there's hypothesis space. We are interested in what is the shape of the Earth. The Earth could be flat, I don't know, could be round, could be could be really weird, I don't know. And then you would probably, maybe you would even pitch them the wrong solution first. You'd be like, oh, flat Earth theory. If the Earth was flat, this is what we would see. Here's a possible solution to the problem, and you would explain to them, and then if the ship is further away, it'll get smaller. You can even explain it to them. You're like, oh, this is what perspective means. If you take something, you move it further away, it gets smaller, and they will think about it, and great. And then you're like, oh, actually, that's not what you see. What you see is this. How does that fit into the picture? And now you're like, wow, wait, but the ship isn't getting just smaller. It's also you only see part of the ship. So what's going on? And then you tell them, well, actually, flat Earth. That's the reason why the flat Earth theory is bogus. That's how we figured out. Actually, the Earth is round, and this is what explains the observation. And you can get them to think about the problem. Okay, this is kind of obvious, but it's also important when you give a talk. It relates to the part about being excited about the thing that you're presenting. If you're if you're not excited about the thing that you're presenting, how's your audience going to be excited about the thing that you're going to be presenting? So when you give a talk, you best find the thing that motivated you, even if you've since moved on. So I have this all the time. I'm sure you'll get into that position as well. You have to present something that you worked on 2 years ago. And you've long moved on, and you actually, you don't want to talk about it. But obviously you don't present it like that, right? Remember what was it that got you excited about that in the first place. And something you can totally do is you can present it. Sometimes it happens to me that the reason why I got excited about something was wrong. like neural fields. The reason why I got excited about it turns out to be wrong. Maybe you remember. So, but instead of just, even if that is true, maybe just tell it like a story, right? Like story time. Vincent was a PhD student in his second year, and Vincent thought that X, Y, Z, and that's why we worked on this, and da-da-da. Well, actually, now it turns out that these things are wrong because, you know, this and this and this. But if you just, like, if you don't get a way of sharing the excitement, why were you excited about working that in the first place, then no one else is going to be excited about your talk anyways, and they're going to think it's a really lame talk. Yeah, so like Bill is actually really good at this. Like Bill, for instance, presents this like deconvolution problem that if you see Bill talk about problems or Antonio talk about problems, both of them are really, really good at like being excited. And that's because obviously they are excited about the stuff. So it's not like they're faking it. But you know, probably you had a reason to be excited about some problem that you worked on, otherwise you probably wouldn't have worked on it. So just remember that excitement and try to like tell people why you were excited about it. Yeah, I think this is the important bit. They want to watch you love something. Right? Like if you give a talk and they feel like you're excited about something, it's like because it's a piece of your personality shining through, right? It's like, so ideally you show them that you're excited about something. Yeah, same thing again. Just be authentic. Don't be afraid to be yourself and to be quirky. People really respond to the human parts of the talk. I guess this is all just saying, like, again, like, talk to people as if you are talking to them and not as if you're giving a talk to them. Yeah, this is kind of just a simple thing. When you end your talk, don't immediately ask for questions. Like, make it clear that the talk is over, you know. Thanks for your, you know, thanks, see you next time, or thank you for your attention. And then after the clapping has died down, then you invite questions. Because otherwise, if you ask for questions, it's going to be an awkward ending. No one's going to know if they should clap or not. And like, then people will roll up for questions. It's not a clear end. Like, when you end your talk, don't immediately ask for questions. Just say like, oh, thank you very much for your attention. And then when everyone is done throwing roses at you, you can continue. And I think this is actually the end of my talk. So thanks for coming today. We're going to end it early today. And I just really can't highlight this enough. When you give your talk next Tuesday, use it as an exercise to train these things that seem very awkward to you. Because you'll never, ever get better at giving talks unless you get over being awkward about walking up to people, talking to people, like taking breaks, you know, like playing with people's attention, making jokes. This will only come if you force it. You have to force it. It's painful. Like, you know, like, how's it called? Like the area of comfort zone. You have to leave the comfort zone, and you have to do it while giving talks. And so the best way to do it is to give lots of talks, but the even better way of doing it is to give talks where no one cares. So, you know, when you give your talk next Tuesday, you know, just try to like think of all the things. Like you can even watch old recordings of yourself, if you have any. Watch an old recording of yourself when you gave a talk, and then make a list of these are the things that I think I should do better, and then make it a point of literally hitting them during your talk. Like if you think you should take more breaks, then literally make it a point of like taking a sip from your water bottle and just looking at people and being silent for 10 seconds, or walking up to people, or making jokes, or you really have to force it. Otherwise, you're never going to fix it. That's it. Thanks so much for coming. See you next. Yeah, so obviously no lecture on Thursday, and then next Tuesday, these project presentations. And I'm going to send out around a Google Sheet, and then everyone can sign up, and it's going to be great.